Yeah, thank you very much. Also for the kind invitation and this great conference, which we were listening since 2 days now. When preparing our presentation, we thought that we would like to bring the two main subjects, futures and heritage, and also education and society closer together. So we have two parts in our presentation. First, presenting the tools, which we also describe in our proceedings, but then also comment shortly on how far these tools could contribute to facilitating digital accessibility to cultural assets. And concerning our conceptual frameworks in terms of assumptions, we think that the question of access is the central issue in dealing with cultural and digital archived data for the future, but that the potential has not been exploited so far. And we also think that easy to use, secure and network-based forms of access can increase both visibility and significance, as well as sustainability and longevity of data. And approaching the subject from the perspective of access and reuse, our tools require server-based infrastructure with ideally collection management or database running with semantic metadata, and all those files should be digitally addressable. So when entering cultural institutions today, one finds quite a number of monitor systems with general information about the institution, respective exhibitions, and so on. And the deeper you get into the gallery space, the more artistic the content on the displays come. And here you see my library and our digital archive, which is displayed in relation to the books to invite people to access the archives too. But most of the time, and sometimes it's important that files are redone and are composed in different exhibitions and so on. And we are not talking about interactive installations, as we saw before, or complex systems, but rather the everyday screen information, which is basically static or possibly dynamic, but with little interaction here. And then the content is very often brought to the devices by hand on digital data carriers. And sometimes even the devices have to be started up every morning by hand and shut down during the evening if you want to save resources or conserve the lifetime of the devices. So our screen system tries to automatize this process. The screens fetch their data from a network and are staffed via proxy. This ensures not only the data to be displayed correctly on the correct display at the correct time, but also to detach the whole system from the internet. We use, for example, outdated Mac computers, which were not longer allowed to connect to the internet.
So, from the network point of view, our system consists of a proxy, which is the center of communication of the InfoScreen system. This proxy is located somewhere in the cloud. All clients will connect via encrypted connection to the proxy and authenticate themselves via a certificate. This way, a very secure VPN-like network is built up. On the display side, the system uses Google Chrome web browser for displaying the content. This means that we can use a powerful multimedia engine of the Chromium system. The InfoScreen client, which is programmed in Go language, which does the connection to the proxy, also controls the web browser via the Chrome debug protocol. This allows us to fully control the content without relying only on JavaScript and HTML techniques. Therefore, we are able to show video, PDF, images, as well as 3D content and animations, everything which is possible with a modern web browser. For autoplay of videos, we had to implement some tricks to make it possible. On the controller side, there's another software piece programmed in Go language, which is responsible for control of the contents on all attached display clients. Here you can see what happens within the encrypted connection. There are several protocols implemented to multiplex between any clients. The gRPC protocol is used for high-speed procedure calls between clients and controllers to send comments to the displays. Via HTTP, it is possible to display content within the secure network to show objects which are not available on the internet. Since we are using old hardware as display clients, we found out that the clock is an issue for displaying multi-client content like tickers or videos moving automatically over many screens and so on. To achieve a common clock, we implemented NTP over gRPC to synchronize all browsers internally. So the display content normally consists of a website and additional data which is JSON encoded. The website can be used on many screens and only the JSON part is different. In this example, you can see a slideshow where JSON consists of a list of URLs with images, timing information, and optional captions. This means that curation of slideshows just required the creation of some JSON files with URLs. For videos, you can specify start and play time if only excerpts shall be shown. Like the display clients, the controller can run on any machine which can connect to the proxy. You can have multiple controllers and therefore they can even run on local laptop. Since the controller exposes a REST API, and you can see here a Windows PowerShell script which configures and starts one display system by loading a website, the JSON parameter into the system and just starting it.
So in addition to automatized feeding of the screens via a command line tool, a web interface was developed that generates screenshots of all running systems in real time. This helps to coordinate and fine-tune your curatorial program. For example, when the screens are displayed at different places in the museum and you can't see all of them exactly. It also helps debugging because you can see if problems occur. And a second thing which you have here with the remote control and the single screen you see here is that you can send, for example, specific images, URLs, or screenshots. Like if an important VIP group comes and you have to show their archive, you are within a few seconds, you have the material on. And also for emergency reason, you can prepare information which could direct the audience to the next emergency exit or inform them in case of a disaster. Another topic I wanted to mention is that using the Chrome web browser as displaying engine is also very useful in the curatorial process of selecting and arranging specific shows, since you do not have to store tons of data locally on your desktop. You just curate your URLs and watch your material. And in addition to your own material, you could send the screen also to different museums, to screens in the public space, or to single private users at home, like in the lockdown situation. Focusing on distributed net communities and the visibility of archived content in addition to human usage or interaction in terms of like classical research situations, we would like to address another target group: machines or audiences which require automatized access to data. Even though this target group is less visible because they do not come on site, they play an increasingly important role for the cultural sector. They intend to see, analyze, and explore cultural data from a distance. At least within the scientific field, the convention of the so-called FAIR principles has been established during the last years to provide specifications on how findability, accessibility, and interoperability are achieved. And since data which can't be reduced or reproduced beyond the very limited scope of quotation, since relatively worthless for many actors, reusability has been added as fourth principle.
So many of the requirements presented here are provided already by existing catalog systems or databases. But the others, which can be technically implemented, are supplemented by our FAIR service. Due to the fact that reusability is mostly a question of licenses, policies, and metadata quality, the FAIR service focuses on the other core areas of the principles: findability, accessibility, and interoperability. Technically, three things are particularly important. A redirector service that makes objects findable even if they are stored in a different location, the documentation of deletions, and the provision of a standardized metadata interface so that data can be accessed automatically. Automated query and reuse of metadata is usually enabled by an OAI PMH interface, and within this interface, the existing metadata schema is mapped to a normalized schema. Currently, the FAIR service supports Dublin Core and the DataSite metadata model due to the fact that these are widely used. The graphic again shows the three core elements of the redirector, the OAI PMH interface for metadata harvesting, and the administration interface with the REST API into which the metadata of the master system are automatically brought. We populate the interface with data in a specific publish to FAIR service process. To store its data, the FAIR service uses its own database. In our case, it's PostgreSQL. This database ensures the persistence of the data. Persistence is ensured in the FAIR service in two ways. On the one hand, the PostgreSQL database holds the descriptive data of the master system. If this system fails temporarily, for example, data can come directly from the FAIR service. Another form or mode of persistence is provided by the so-called redirector. Here the objects are, so to speak, followed, even if their physical location on the storage system or the archive system changes. The figure also shows external services that are necessary for the creation of so-called persistent identifiers. These identifiers are usually assigned and managed by globally recognized agencies. We use the commonly known PIDs, persistent identifiers, from handle.net and DOEs from DataSite. For each dataset, the FAIR service creates a new handle using a local service programmed in Go language. These handles can be compared to a name server record, but at the URL level of each single object. This means that the handles and their associated target URLs are managed locally in a database and can be retrieved at any time from the globally managed handle.net server. For using handle, you first have to request a so-called handle prefix at handle.net. This prefix and the handle server is then set up and managed locally. The handle prefix can be compared to an ordinary domain name, except that handle has some claim on sustainability. DataSite's DOIs use the same technology, but DOIs are centrally managed by DataSite and are also enriched by metadata. They are mainly used in the context of scientific applications. If you look at the data interface of the OAI PMH service with a web browser, it looks like something like this. On the left side, you see the Dublin Core, and on the right, the DataSite metadata schema of the same dataset. In reality, however, the OAI PMH interface delivers pure XML, which is usually rendered graphically in the browser using an XML style sheet. For controlling which content is made publicly available via the FAIR service, a reduced web interface was developed. On the left side, you can see that in the FAIR service, there are automatically created handles for each record. On the right side, you can see a detailed view of such a dataset with the possibility to create an additional DOI by using the Create DOI button. Since DOI facilitates citation in scientific publication and enjoy a higher reputation there, it can make sense to use a DOI in addition to the handle, which also generates persistence. We don't want to go into the difference between DOI and handle here. What seems more important is that you can see here the DOI at the DataCite website, which refers to the redirector of the FAIR service, which leads back to our own catalog system.
And in the catalog system, the material is displayed like always. In our case, we have video and audio data, and also PDFs, or in this case, we have 3 PDFs and a lot of metadata, just as much as you want to show. The last thing we wanted to mention regarding the FAIR service is that it is designed as a multi-tenancy software. This means that it is capable of managing different collections with varying policies, both in-house and also across institutions. So not each institution needs to run its own FAIR service to become fair, but institutions can cooperate and collaborate without visible kind of interference regarding policies or display conventions. Given the FAIR service as a metadata harvesting system, our InfoScreen system for curated slideshows or making archival goods visible on different displays, and the yesterday mentioned cooperation of collaborating archives, Jürgen envisioned yesterday this small chart of possibly sharing infrastructure for all this kind of content. But this is not our topic. We wanted to comment on within this education and society requirements, we wanted to say that with a FAIR service, even smaller cultural institutions can easily drive their data collections, both transparent and open, on the one hand, and also bring it to a scientifically accepted format. This is especially important for funding and cooperation sometimes. Both systems, the FAIR service and the InfoScreen system, allowed cultural objects or data to reach outside the institutional framework and thus transcend limitations and also reach a broader public, both of institutional stakeholders as well as persons. And last but not least, collaboration and cooperation are fostered through both of the tools. You might ask if the community is already ready for these kind of tools, especially if you do not focus on the community which is present on the conference, which means people who work within the media art field for a long time, but it's a broader public and possibly also in other art forms. We would say yes. We just were able to be hosts of an open community call on performance art in Switzerland, which was a base for the Bang Bang exhibition, which is currently up in the Tanguy Museum in Basel. Unexpectedly, more than 2,700 artists and collectives were contributing more than 1,500 entries. And here you see the red line. Possibly you can identify it as a section of a bigger picture of the 12,500 images, about 800 PDFs, about 1,100 video materials with 240 hours to watch and 8 hours to listen. And this all within 3 to 5 months. This is how a normal entry looks like. You have a video, you have image material, and also a lot of metadata, especially the festivals, which are also sometimes captured within one record. We sometimes have more than 40 entries, but there are also these kind of entries where only few PDFs are left, a link to a Vimeo website, and the comment that the artist brought all the material to a cultural collection and has no data left. To say it different, we do not want without providing open interfaces to our collections, which allow others to have access and to refer to data in a proper way, cultural institutions run the risk to become stakeholders which produce this kind of gaps. We rather prefer to bring artworks of historical, or in this case, technological obsolescence again to life. What you see here is a Salon Digital, which was produced by Walter von der Cruyssen in 1997 for the opening of Center for Art and Media in Karlsruhe, in order to show the collection of the then new museum before entering the museum in an interactive computer game-like environment. For Bang Bang, the historical work was restored and is now showing the extensive database on performance art. And if you want, you can visit the website. So we are at the end. Thank you very much for your presentation, for your listening.